Class 12th, Subject Physics, 5th chapter, Oscillations. From the chapter, let us see numericals from exercise. Numericals from exercise. The very first numerical, that is question number 8, is given as: at what distance from the mean position is the speed of a particle performing SHM half its maximum speed, given that path length of the SHM equal to 10 centimeter. And so the given data is velocity phi is equal to half of maximum velocity, that is phi equal to half phi max. Then path length of SHM is 10 centimeter, therefore it is 2a equal to 10 centimeter, and therefore amplitude of SHM a is equal to 5 centimeter, and we have to find the distance x from the mean position at which phi is equal to half phi max. Now we know that the velocity of a particle performing SHM is given by the formula phi equal to omega root of a square minus x square, and the maximum velocity phi max equal to a omega. As condition is given that phi is equal to half phi max, therefore putting the values of phi and phi max, we will get omega root of a square minus x square is equal to half a omega. Therefore, cancelling omega on both sides, we will get square root of a square minus x square equal to half a. Then squaring on both sides, we will get a square minus x square equal to a square by 4. From this we can write x square equal to a square minus a square by 4, that is x square equal to a square minus a square by 4. Then we can simplify it as 4a square minus a square upon 4, that is 4a square minus a square, that is 3a square, and upon 4, that will be the value of x square, and therefore x square will be equal to 3a square by 4, and therefore we can write x is equal to root 3 by 2a. But value of root 3 is 1.732. It will be divided by 2 and then into 5. Then root 3 by 2, its value, that is 1.732 upon 2, its value is 0.866, and it will be multiplied by 5, and therefore x will be equal to 4.33 centimeter. X is equal to 4.33 centimeter, which is the required answer. Then we will go for next numerical, that is question number 9, in which it is given that in SI units the differential equation of SHM is d square x by dt square equal to minus 36x. Find its frequency and period. And therefore the given data for this 9th numerical is the differential equation of SHM is given as d square x by dt square equal to minus 36x, and from this we have to find out the frequency f and the period t. Now we know the differential equation of SHM. The general form of differential equation of linear SHM is d square x by dt square equal to minus omega square x, equation number 1. d square x by dt square equal to minus omega square x. And the given equation is, the given differential equation is d square x by dt square equal to minus 36x, equation number 2. Comparing these two differential equations, we can write as LHS are the same, RHS must be same, that is minus omega square x must be equal to minus 36x, and therefore from 1 and 2 we can write minus omega square x equal to minus 36x, minus minus will become plus, then x on both sides will get cancelled, and therefore we will get omega square equal to 36, or taking square root omega will be equal to 6. But we know that omega is equal to 2 pi f. Omega is equal to 2 pi f, and that will be equal to 6. And therefore, as 2 pi f is equal to 6, therefore f will be equal to 6 by 2 pi. F is equal to 6 by 2 pi, that is 6 upon 2 into 3.142, that will be equal to 6 upon 6.284, which comes out to be 0.9548 Hertz, 0.9548 Hertz. So this will be the frequency, and from this, as period is equal to reciprocal of frequency, as t is equal to 1 by f, therefore t will be equal to 1 upon 0.9548, 1 upon 0.9548, which comes out to be 1.047 second, 1.047 second, and therefore these are the two, that is frequency 0.9548 Hertz and period 1.047 second are the required answers. Now let us go for next numerical, that is question number 10, which is stated as: a needle of sewing machine moves along a path of amplitude 4 cm with a frequency 5 Hz. Find its acceleration 1 by 30 second after it has crossed the mean position. So in this numerical, given data is amplitude of Shm, that is A is equal to 4 cm, equal to 4 into 10 raised to minus 2 meter. Then frequency f is equal to 5 Hertz. Then time interval t equal to 1 by 30 second, 1 by 30 second, and we have to find out the magnitude of acceleration. Now we know that omega equal to 2 pi f, and therefore as omega equal to 2 pi f, therefore we can write omega equal to 2 pi into value of f is 5, and therefore omega will be equal to 10 pi radian per second, 10 pi radian per second. Now the magnitude of acceleration, will be given as magnitude of A equal to omega square x, which will be written as omega square into A sin omega t, assuming that the needle starts its motion from the mean position, and therefore we can write omega square equal into A sin omega t, that will be equal to magnitude of acceleration. Putting the values, we will get omega equal to 10 pi, therefore 10 pi square into A is 4 into 10 raised to minus 2 into sine of omega t, means 10 pi into 1 by 30, whose value comes out to be pi by 3, and therefore further we can write 10 pi square into 4 into 10 raised to minus 2 into sine pi by 3, and that will be equal to 10 pi square into 4 into 10 raised to minus 3 into sine pi by 3 is root 3 by 2, and therefore further we can write 10 into 9.872 into 4 into 10 raised to minus 2 into 0.866. So root 3 by 2 is 0.866. That will be written as, if you calculate this product, then it comes out to be 34.20 meter per second square. This will be the magnitude of acceleration. Then we will go for next numerical, that is question number 11, which is given as the potential energy of a particle performing linear SHM is 0.1 pi square x square joule. If mass of the particle is 20 gram, then find the frequency of SHM. And therefore, in this numerical, the given data is potential energy is 0.1 pi square x square joule. Then mass m is equal to 20 gram, that will be equal to 20 into 10 raised to minus 3, that is 2 into 10 raised to minus 2 kilogram. Then potential energy is given by the formula in order to find this frequency f. So potential energy equal to half m omega square x square. Further, it will be written as half m 4 pi square f square into x square. 2 pi f is omega, its square is 4 pi square f square, and into this x square. Now, as potential energy equal to half m into 4 pi square f square x square, but we are given that potential energy 0.1 pi square x square, and therefore we can write half m 4 pi square f square x square must be equal to 0.1 pi square x square. Cancelling pi square x square on both sides, we will get 2m f square equal to 0.1. 2m f square equal to 0.1, and therefore f square will be equal to 0.1 upon 2m. F square equal to 0.1 upon 2m. Putting the values, we will get 0.1 upon 2 into 2 into 10 raised to minus 2. 0.1 upon 2 into 10 raised to minus 2, and therefore f square comes out to be 2.5. Therefore, taking square root, f is equal to square root of 2.5, which comes out to be 1.581 Hertz. 1.581 Hertz. Then we will go for next numerical, that is numerical number 12, which is given as the total energy of a body of mass 2 kg performing SHM is 40 joule. Find its speed while crossing the center of the path. And therefore, for this 12th numerical, the given data is m is equal to 2 kg, that is mass, energy E equal to 40 joule, energy equal to 40 joule, and we have to find out phi max. Now, when that body is crossing the mean position, at that time its velocity will be maximum, and so that the energy E will be purely kinetic energy. As that body is crossing the mean position, its velocity phi is equal to phi maximum, and as velocity is maximum, it will be having purely kinetic energy. That is, that total energy E will be equal to kinetic energy of that body, and therefore we can write half m phi max square, half m phi max square, that is kinetic energy, will be equal to total energy. And therefore from this, phi max square will be equal to 2e upon m. Phi max square equal to 2e upon m, and therefore we can write, taking square root, phi max equal to square root of 2e by m. Putting the values, we will get square root of 2 into 40 upon 2, 2 will get cancelled. We will get a square root of 40, which comes out to be 6.324 meter per second. This will be the maximum speed of that body while crossing the mean position. Now we will go for next numerical, that is numerical number 13, which is stated as a simple pendulum performs SHM of period 4 seconds. How much time after crossing the mean position will the displacement of the bob be 1/3 of its amplitude? And therefore for this numerical, period t is given 4 seconds. For 13th numerical, t is equal to 4 seconds. Displacement x is equal to 1/3 of its amplitude, that is x equal to a upon 3, where a is the amplitude of SHM, and we have to find out the time interval t. Now the displacement of a particle performing SHM and starting from mean position is given as, so when any particle is performing linear SHM and it is starting its motion from the mean position, at that time displacement x is equal to a sin omega t. That will be written as a sin omega is 2 pi by t and into t. So a sin 2 pi by t into t. Therefore a sin 2 pi by t into t equal to a by 3. A sin 2 pi by t into t, that is equal to a by 3. Therefore further we can write 2 pi by t into t. 2 pi by t into t will be equal to sine inverse of 1 by 3. Sine inverse 1 by 3, cancelling here a on both sides, we will get 2 pi by t into t is equal to sine inverse of 1 by 3. And therefore we can write 2 pi by t into t is equal to sine inverse of 1 by 3 means 0.3333, which comes out to be 19.47 degree. 19.47 degree, which will be converted into radian as 19.47 into pi upon 180 radian. 19.47 into pi upon 180 radian, and therefore further we can write 2 by 4 t, that is 2 by 4 t, because capital T is equal to 4, and therefore we can write 2 by t or 2 by 4 into t, that will be equal to 19.47 upon 180. 19.47 upon 180. Therefore we can write t is equal to 19.47 upon 90. Here it was 2 pi by t into t, its value was 19.47 into pi by 180. Pi will get cancelled on both sides, and therefore at last we will get value of t is equal to 19.47 upon 90. That comes out to be 0.2163 second, and which will be the required answer. And now we will go for next numerical, that is numerical number 14, which is stated as numerical number 14 is given as a simple pendulum of length 100 cm performs SHM. Find the restoring force acting on the bob of mass 50 gram with the displacement from the mean position is 3 cm. So when the displacement of that bob is 3 cm from the mean position, we will have to find out the restoring force acting on it. And therefore for this numerical, given data is L is equal to 100 cm, that is equal to 1 meter. Then M is equal to 50 gram, that is equal to 5 into 10 raised to minus 2 kilogram. Then displacement x is equal to 3 centimeter, that is equal to 3 into 10 raised to minus 2 meter. Then g is equal to 9.8 meter per second square, and we have to find out the restoring force F. The restoring force acting on that bob is given by the formula F is equal to mg sin theta. So in case of simple pendulum, the restoring force acting on the bob is given by the formula mg sin theta. But in this case, theta is very small, and therefore sin theta will be taken as theta, and therefore F will be equal to mg theta. Therefore we can write F is equal to, in this case, theta is equal to x upon L, that is arc upon radius, that is displacement from mean position of that bob divided by length of the string, that is F is equal to mg into x by L. That will be written as 5 into 10 raised to minus 2 into 9.8 into 3 into 10 raised to minus 2 upon 1. Now F will be equal to 147 into 10 raised to minus 4. If you calculate all this product, then it comes out to be 147 into 10 raised to minus 4, which will be equal to 1.47 into 10 raised to minus 2 Newton. 1.47 into 10 raised to minus 2 Newton. That will be the value of restoring force. And then we will go for question number 15, which is given as find the change in length of seconds pendulum if the acceleration due to gravity at the place changes from 9.75 meter per second square to 9.8 meter per second square. And therefore in this numerical given data is two values of acceleration due to gravities are there, that is g1 equal to 9.75 meter per second square, g2 is equal to 9.8 meter per second square, and for these two values of acceleration due to gravity we have to find out the change in length, that is delta L of the seconds pendulum. For that, the length of seconds pendulum is given by the formula. Length of seconds pendulum is given by the formula L is equal to G by pi square. L is equal to G by pi square. Therefore, L1 is equal to, we can write G1 upon pi square. L1 is equal to G1 by pi square, and L2 is equal to G2 by pi square. L2 will be equal to G2 by pi square. In this case, G2 is greater than G1, and therefore L2 must be greater than L1, and therefore the change in length delta L will be equal to L2 minus L1. As L2 is greater than L1, since G2 is greater than G1, and therefore we can write delta L is equal to L2 minus L1, that is equal to G2 by pi square minus G1 by pi square. G2 by pi square minus G1 by pi square. Taking common 1 upon pi square, we will get delta L is equal to 1 upon pi square into G2 minus G1. 1 upon pi square into G2 minus G1. And now putting the values, we will get delta L is equal to 1 upon 9.872, that is the value of pi square here, into 9.8 minus 9.75. 9.8 minus 9.75, which will be equal to 1 upon 9.872. 1 upon 9.872 into 0.05 into 0.05. If you calculate this quotient, then we will get delta L equal to 0.0051 meter. 0.0051 meter. This will be the change in length of that seconds pendulum when acceleration due to gravity changes from 9.75 meter per second square to 9.8 meter per second square.